All right, 11.4 is about circumference and arc length. And we talk about circumference because an arc length is a portion of the circumference. So in the middle of these notes, this whole topic is going to be circumference. All right, so our definition of circumference is the distance around a circle. The distance around a circle. And you've got two formulas for this. The first formula, you can use the radius. So circumference equals 2 pi r, where r represents the radius of the circle. Or you can use circumference equals pi d, where d is the diameter of the circle. And of course, if you don't have a pi symbol on your calculator, you can round it to 3.14 whenever you're using the formula. All right, now then, the diameter of a circle, make sure you understand what the diameter is. It's the distance across the circle, through the center. Okay, so if you were to draw a circle, have the center point, this is your diameter. Okay, and the diameter is equal to 2 radii. Radii is plural for radius. All right, now then, make sure you understand what a radius is. A radius, this is the distance from the center of a circle to the circle's perimeter. All right, so a radius is basically half the diameter. Here's your circle. Here's the center. There's the radius. So you only go halfway. So a radius equals half a diameter. All right, now, finding circumference, this is how you would use the formula. All right, find the circumference if the radius is 4. If the radius is 4. All right, so here's your circle. You've got a radius. The length is 4. So since I have the radius, I'm just going to use this formula right here, 2 pi r, and I'm going to plug the 4 in place of the r. If I multiply that, I get 8 pi. Now, sometimes you're asked to leave your answer in terms of pi, so you would just leave it like this. If not, if it says to multiply it on out, then it would be approximately 25.13, rounded to the 100th place. All right, so those are your examples of circumference. Now then, the next part of these notes has to do with the actual arc lengths. Okay, so that's going to be our topic here in the center, arc lengths. And an arc length is an actual piece of the circumference. So to define it, here's our definition. Okay, it is a portion of the circumference. It is a portion of the circumference and it is measured in units, not degrees, because we had talked about arc measures in Chapter 10, This is talking about the actual length. So by units, we're talking about inches, feet, meters, centimeters, whatever the case may be. Okay, that leads us to an arc length corollary. An arc length corollary, which is very wordy. If you remember, a corollary is just like an addendum, something extra added to a theorem that we've already dealt with. This is going to be very wordy, but after I explain it, or state it, we're going to explain it in terms of a formula. So the arc length corollary is the ratio of the length of a given arc to the circumference is equal to the ratio of the measure of the arc to 360 degrees. Okay, what that means. Here's the formula. Because if you're like me, you would read that and go, what did I just read? All right, we're going to draw a little picture over here in the corner. And this is going to be circle P. So I'm going to put a P right there at the center point. I'm going to have 2 points on the perimeter of the circle. They're going to be points A and B. Now I'm going to draw a radius to each of them. I'm going to label PB with an R. That's our radius. Okay, what this whole thing is stating is that to find the arc length, like if I wanted to find the length of arc AB, how long it is. Arc length of AB. Okay. It is a portion of the circumference. So I'm going to use 2 pi r. That's my formula for circumference. And it is equal to the measure of arc AB over 360 degrees. And by the measure of arc AB, that's the degree of the central angle right here. Okay, so this is just a proportionate ratio that we're going to use. So if I'm trying to find this part here, this is my unknown, that's an x. I would plug my value in for my radius here and the degree of my central angle here. So let's we're going to do a practice problem. But first, I want you to remember, this is very important. Okay, the measure of an arc equals the degree of its central angle. That's one note. The other note, the length of an arc equals a portion of the circumference. Okay, so they are different. These two numbers represented right here in the formula are different. This is the actual arc length. This is the measure of the arc, which is the degree of its central angle. Okay, so now to practice that formula in this example right here, we've got a radius that equals 8, a central angle that equals 60 degrees, and we're going to plug that into our formula. So I want to find, it says find the length of the red arc. Well, this right here. We're finding arc AB right there. It's not red. Apologize for that. All right, so I don't know the length of my arc. That's x. But I do know my formula for circumference. It's 2 pi r, and r is 8. And that's equal to my arc measure, which is my central angle, 60 degrees, out of a total 360 degrees. All right, now, when I do my cross products to solve for this, okay, it's going to be 360 times x is equal to 60 times 2 pi 8. Well, 2 times 8 is 16. So that's times 16 pi. So what I get when I multiply that out is 60 times 16 pi. It's 3015.9 approximately. And then I'm going to divide that by 360, and I'm going to get 8.38. All right. So this is my arc length. My whole entire circumference is 16 pi. The length of my arc is 8.38, a portion of that. So those are some quick examples of how to use your arc length formula.